Good evening to all of you. I am Mr. Nedram Tundre, PGT Physics. Now, in today's lecture, we discussed about uh, the modern physics chapter dual nature of radiation and matter. Topic name is photoelectric effect. So, now in this modern era, we all are familiar with mobile phone. Do you know in our mobile phone have included a special type of facility if we allowed the brightness level of our mobile phone in automatic mode, then we experience, if we come into the contact of sunlight, then the brightness level of our mobile phone will be automatically increases, and just opposite, if we come into the shadow region, then we experience the brightness level of our mobile phones will be automatically decreases. Do you know how this is happened? What is the reason for this incident events? Actually, in our mobile phone included inbuilt a special type of sensor known as a ambient sensor, which is work on the basis of photoelectric effect. So, in this lecture, we discussed about photoelectric effect, what is photoelectric effect, and what are the characteristics for these photoelectric effects, criterion for this effect. So start the effect, photoelectric effect. So start today's topic, which is photoelectric effect. Photoelectric effect. This is the topic of part 2 physics, dual nature of radiation and matter. Now, the photoelectric effect, from the name, photo means light. According to modern physics, the nature of light is dual nature, and the theory is accepted. The light is made of very small tiny particles known as photons. Then the light is known as a photo. So from the title, the effect is photoelectric effect, means photoelectric effect, that means the effect in which the electricity will be produces due to electricity will be produces due to photo means light. Simply we understand the photoelectric effect, electricity will be produced due to photo, that means light. Now, as per the syllabus, according to syllabus, the definition of this effect, the phenomena of the definition, the phenomena of eject an electron from the metal surface from the metal surface when radiation of high frequency or low wavelength is incident on metal surface. For this, we consider a metal surface. Let's suppose this is a metal surface. There is present large number of free electrons. Now, when radiation of high frequency or low wavelength is incident on metal surface, then the electrons may be ejected out from this metal surface. Then this phenomena is known as a photoelectric effect. Now the condition for this electron emission, the energy of this radiation, that means light, the energy of radiation will be greater than the work function of this metal surface. This is the condition for photoelectric emission. Let the energy of incident radiation, the energy of incident radiation will be E. Then we know that E is equal to h nu, where h is a Planck's constant. Its value is 6.626 cross 10 to the power minus 34 joule second, and nu is a frequency of radiation, and also E is equal to h c upon lambda, since nu is equal to c upon lambda. Then Then now from this energy we calculate the equation for maximum kinetic energy of incident radiation, which equation is given by the great scientist Albert Einstein, and for this great discovery he got the Nobel Prize of Physics in 1905. Nobel Prize for his great discovery. Actually, the Albert Einstein is giving the equation for maximum kinetic energy, equation for maximum kinetic energy of emitted electrons. Now, for this great discovery he got the Nobel Prize. So we derived the equation for maximum kinetic energy, but before this we also know about the work function. What is work function of metal surface? Now work function the minimum amount of energy which is required by metal for ejection of electrons, and it is represented by phi. So for emission of electrons, E must be greater than or equal than work function. So we derive the equation for maximum kinetic energy. The maximum kinetic energy Ke max is equal to the energy of incident radiation minus work function of the metal surface. But now we putting the value of E, then we get the equation of maximum kinetic energy, H nu minus phi, and Ke max is equal to Hc upon lambda minus 5. These three equation is known as a equation for maximum kinetic energy, and for this equation the Albert Einstein got the Nobel Prize. Thank you.